Determining the ampacity of a 4 American wire gauge belting cable when installed in a raceway or seal tight requires understanding the National Electrical Code, or NEC, guidelines for conductor derating. The NEC mandates that the ampacity of conductors in raceways be adjusted downwards based on the raceway fill, which is the percentage of the raceway's cross-sectional area occupied by the conductors. Without a specified raceway fill percentage, providing an exact ampacity adjustment is impossible. However, given that the open-air rating for the 4 American wire gauge belting cable is 100 amps, a reasonable estimate can be made using general guidelines. The ampacity reduction for conductors in a raceway or seal tight typically ranges from 10% to 50%, depending on the raceway fill and ambient temperature. This range is broad because different types of raceways, such as electrical metallic tubing, or rigid metal conduit, or RMC, and flexible metal conduit, or FMC, have different heat dissipation characteristics, and the number of conductors within the raceway significantly affects heat buildup. To estimate the ampacity, the formula used is estimated ampacity equals open air rating times 1 minus adjustment percentage. For example, assuming a conservative adjustment percentage of 30%, which falls midway between the 10% and 50% range, the calculation would be estimated ampacity equals 100 amps times 1 minus 0.30, which equals 70 amps. This means that under these assumptions, the estimated ampacity rating for the 4 American wire gauge belting cable in the raceway is approximately 70 amps. However, it is crucial to understand that this is merely an estimate. The actual ampacity can vary significantly based on the specific raceway or seal type used, the number of conductors in the raceway, the ambient temperature, and other factors affecting heat dissipation. Therefore, relying solely on this estimate for electrical installations is not advisable. Always refer to the manufacturer's specifications for the specific cable and raceway being used. Belting cable, like all conductors, has specific ampacity ratings based on its construction and insulation type. The raceway also has its own thermal characteristics. Consulting these specifications will provide a more accurate understanding of the cable's ampacity under the specific installation conditions. Moreover, consulting with a qualified electrician is essential. A licensed electrician can assess the specific installation conditions, consider all relevant factors, and ensure that the wiring is installed safely and in accordance with all applicable codes and regulations. They will also be able to perform the necessary calculations and select the appropriate overcurrent protection to protect the circuit. Several factors can influence the ampacity of conductors in raceways. Firstly, the number of conductors. The more conductors in a raceway, the more heat is generated, and the lower the ampacity of each conductor must be. NEC Table 310.15. A3. It provides adjustment factors for the number of current carrying conductors in a raceway or cable. Secondly, the ambient temperature. Higher ambient temperatures reduce the ability of conductors to dissipate heat, and the ampacity must be adjusted accordingly. NEC Table 310.15. A2. It provides correction factors for ambient temperatures other than 30 degrees Celsius or 86 degrees Fahrenheit. Thirdly, the type of raceway. Different types of raceways have different heat dissipation characteristics. For example, metal raceways dissipate heat better than non-metallic raceways. Fourthly, the insulation type. The conductor's insulation type affects its ability to withstand heat. Common insulation types include THHN, THWN, and XHHW, each with different temperature ratings. Fifthly, the length of the raceway. In long raceways, heat can build up more than in short raceways, potentially requiring further ampacity adjustments. To accurately determine the ampacity of a 4 American wire gauge belting cable in a raceway, follow these steps. 1. Gather information about the installation. This includes the type of raceway, the number of conductors in the raceway, the ambient temperature, and the length of the raceway. 2. Consult the NEC. Refer to NEC Tables 310.15. B2. IN 310.15. B3. To determine the applicable adjustment and correction factors. 3. Calculate the adjusted ampacity. Multiply the base ampacity of the 4 American wire gauge Belding cable by the adjustment and correction factors. 4. Verify the results with a qualified electrician. Ensure that the calculated ampacity is appropriate for the specific installation conditions and complies with all applicable codes and regulations. In addition to ampacity directing, voltage drop is another important consideration when installing conductors. Voltage drop occurs when the voltage at the load is less than the voltage at the source due to the resistance of the conductors. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. To minimize voltage drop, use larger conductors or run conductors a shorter distance. A formula for calculating voltage drop is voltage drop equals 2 times K times I times D divided by circular mils, where K is the constant representing the direct current resistance for 1 circular mil-foot of conductor, I is the current in amps, D is the one-way distance in feet, and circular mils is the circular mil area of the conductor. For example, consider a 240-volt circuit with a 20 amps load and a distance of 100 feet using 12 American wire gauge copper conductors. The K factor for copper is approximately 12.9. The circular mil area of 12 American wire gauge wire is 6,530 circular mils. Using the formula, voltage drop equals 2 times 12.9 times 20 times 100 divided by 6,530, which equals approximately 7.9 volts. The percentage voltage drop is 7.9 volts divided by 240 volts, which equals approximately 3.3%. In this case, the voltage drop exceeds the recommended 3% limit for branch circuits, so larger conductors or a shorter distance would be necessary to reduce the voltage drop. When working with electrical systems, safety is paramount. Always follow safe work practices and wear appropriate personal protective equipment, or PPE, such as safety glasses, gloves, and insulated tools. Before working on any electrical circuit, de-energize the circuit and verify that it is de-energized using a voltage tester. Never work on live circuits unless absolutely necessary, and then only with proper training and precautions. Grounding is another critical aspect of electrical safety. Grounding provides a low resistance path for fault current to flow back to the source, which helps to trap the overcurrent protection device and prevent electrical shock. Ensure that all electrical equipment is properly grounded in accordance with the NEC. Ground fault circuit interrupters, or GFCIs, are also essential safety devices. GFCIs protect against electrical shock by detecting ground faults and quickly interrupting the circuit. Install GFCIs in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. Surge protection is important to protect sensitive electronic equipment from voltage surges caused by lightning or other electrical disturbances. Surge protective devices, or SPDs, divert excess voltage away from the equipment and protect it from damage. Install SPD at the service entrance and at individual equipment locations. Regular maintenance is essential to ensure the safe and reliable operation of electrical systems. Inspect wiring, connections, and equipment regularly for signs of damage or wear. Replace any damaged or worn components promptly. Test GFCIs and arc fault circuit interrupters, or SIs, regularly to ensure that they are functioning properly. Keep electrical panels and equipment clean and free of obstructions. Ensure that all electrical work is performed by qualified and licensed electricians who are familiar with the NEC and local codes. Permits and inspections may be required for certain types of electrical work. Understanding and adhering to these safety practices will help prevent electrical accidents and ensure the safety of people and property. Remember that electrical work can be dangerous, and it is always best to consult with a qualified electrician if you have any questions or concerns. Regarding the specific scenario of a 4 American wire gauge Belding cable in a 15-foot raceway with a 460/3-phase 60 Hz inline voltage, several additional factors should be considered. Firstly, the type of load connected to the circuit. The type of load, such as a motor, lighting, or heating element will affect the current draw and the required ampacity of the conductors. Secondly, the starting current of motors. Motors typically draw a much higher current when starting than when running. The conductors must be sized to accommodate the motor's starting current. Thirdly, harmonic currents. Nonlinear loads, such as electronic ballasts and variable frequency drives, can generate harmonic currents, which can overheat conductors and equipment. The conductors must be sized to accommodate the harmonic currents. Fourthly, the voltage drop. With a 460-volt system, voltage drop can be a significant concern, especially over longer distances. Use the voltage drop formula to calculate the voltage drop and ensure that it is within acceptable limits. Fifthly, the overcurrent protection. The overcurrent protection device, such as a circuit breaker or fuse, must be sized to protect the conductors from overload and short-circuit conditions. The overcurrent protection device should not exceed the ampacity of the conductors. Sixthly, the grounding. Ensure that the equipment is properly grounded in accordance with the NEC. Use a separate equipment grounding conductor and bond all metal parts of the equipment. Seventhly, the labeling. Label all electrical panels, circuit, and equipment clearly and accurately. This will help prevent confusion and ensure that the electrical system is properly maintained. Eighthly, the documentation. Keep accurate records of all electrical work, including wiring diagrams, equipment specifications, and inspection reports. This documentation will be helpful for future maintenance and troubleshooting. In summary, determining the ampacity of a 4 American wire gauge belting cable in a raceway requires careful consideration of several factors, including the raceway fill, the number of conductors, the ambient temperature, the type of raceway, the insulation type, the length of the raceway, and the specific application. Always consult the manufacturer's specifications, the NEC, and a qualified electrician to ensure that the wiring is installed safely and in accordance with all applicable codes and regulations. Remember that electrical work can be dangerous, and it is always best to err on the side of caution. If you have any questions or concerns, consult with a qualified electrician.